So can we start now, or you want us to wait?
Yes, I think you can start now.
Okay. So welcome back, everybody. So we'll continue off. So welcome back, everybody. So we'll continue with our session. So welcome back, everybody. So we'll continue with our session. So earlier, Rahul was showing you how you could typeset in the TechFolio tool, as in how you can typeset mathematics in within the tool beautifully. So now, before we move on to the next session, which is about how bibliography can be typeset, various forms of using the BibTeX database and so on. Before we move into that, let us understand how a journal production house works. So I had started about this earlier, but I didn't go into the details. So when a publisher submits a document with the publishing house, then that particular document comes to us for typesetting. So generally, a notification is sent, and the notification comes to the tracking system. And from the tracking system, what first happens is
Sir, there's an echo coming. I think you have two connections at your place.
One is only CVR and another is CVR and Rishi CVR.
Okay, just a moment, please.
CVR. Just mute one.
yeah. So are there two people now, or is it okay?
No, this is fine now.
This is fine.
Okay. Okay, so we'll continue. So what happens is the document comes to the publisher. So before the document comes to the publisher, what first happens is a usability check. So each and every publisher will have their own specifications, which has to be adhered to by the author. So this is what Rishi was initially explaining, all the various guidelines that you should follow when you're submitting a particular document with the publisher. So the usability checks would be performed, and from the usability checks, then the particular source file is sent to the typesetter. So the typesetter, depending upon the strategy or the type of file that they need to work on, whether it is a text file, dot file, XML, they'll decide what they have to do. So once that is done, in our case, what the typical operation that is happening is a single operator starts to work on that particular LaTeX file from start to end. So if you take any article, an article will have various sections associated with that particular article. So you will have a part which is the head. You will have something which is called as the body. You will have math. You will have table. You will have tail. Yeah, and all of these put together forms the final entire LaTeX document. So in our case, what we do is we split the entire document into various heads or sections like head, body, math, table, tail, and then each and every operator picks up their specific part of the document which they need to process. And then once they pick up those things, they load it into the TechFolio system, and within the Techfolio system, they will be doing their processing. So in this case, say for example, how Rahul had been doing the work, Rahul, if this is a math operator, needs to only specifically focus on the math part. So even though an article contains lot of math references, lot of tables, a math operator at a production house will only be bothered about the math which is there within the entire document. Similarly, a tail operator will only be focusing on the tail part, where related to references, related to the bibliography, and that's all that they would be looking at. And that's how the processing happens at STM. So this is something which is very peculiar for us. Mostly other typesetters do not do this sort of a processing. And once all of the various stages involved in it are completed, all of that will be merged together. So over here you can see head, body, math, table, source, and tail. All of them is combined together. And like how the initial document, the LaTeX document initially came to the typesetter, it is merged back into one single document. The difference is the structuring, all of that work happens in the individual stages, and finally you have a merged document. Now from the merged document, you move on to the next stage where you see Neptune. This is the author proofing system, wherein the LaTeX file itself is sent back to the author. The author makes the corrections within that same Neptune system. And once the Neptune system, the corrections are made, the file comes back to the typesetter, wherein the final work is done, the pagination is done. You generate the final PDFs, XML, everything, and then it is sent back to the publisher. So this is the general workflow that is present wherein it comes to us. Now, again, we'll move on to the Techfolio system. So wherein Rahul showed you how the Techfolio system works when it comes to typesetting mathematics. Similarly, we look at how a bibliography will be typeset using the Techfolio system. Before that, let's have a very simple video which explains the various features that you would see within the Techfolio system. So I'll play a recorded video. This will help you understand what is Techfolio.
Hello everybody, this is a live demo of Techfolio, which is a cloud-based complete journal production system. Techfolio can produce standards compliant, hyperlinked, bookmarked PDF output directly from XML and text sources, even if they contain heavy math. It is a complete journal production system and can additionally do strip-ins, DUI lookup, demonstration will give you an idea of the various features of Techfolio. Now let us log into the system. Techfolio can be accessed from the cloud, so it has its own login system, and once you log in, it comes up with the interface on screen. The entire tool can be split into 4 quadrants. On the left, what you see is the file manager. On the central half, what you see is the editor. What you see on the right is the PDF viewer or the output viewer. And on the bottom, what you see is the log viewer. So generally, the input would be a text source. And once you load the text source, in case when you do a compilation or so on, if you get errors, those sort of errors can be seen in the log viewer. Now let's start off with the demo by loading a file. So the file manager has a lot of options, so you can load your own files into the system and start working on them. So in this case, I'm going to start loading a file and then working on it. So we have an upload button over here. So using the upload, you can actually load single files or multiple files. In this case, I'm doing it again. So once the file is loaded, I can actually click on the file manager, do an unzip of it. A lot of operations are allowed within the file manager, just as you would see with a regular file manager. You can upload, you can download, you can delete, you can create a new folder, you can edit an existing document with it, like a text file and so on. You can view a text file, you can load a PDF. All these functionality has been provided into the file manager. Now I've loaded the file. So I will double click on it, it opens into that particular folder. Now I'm load the text file into the editor. Once the text file is loaded into the editor, I can see the entire text file loaded. And in case if you feel that the font size is too low or so on, I can increase the font size to whatever I would like. So this helps naturally most of the people who are working on the tool to easily identify text and so on. Now, once the file has been loaded, you have the option of creating a PDF or an XML output, or from the XML, you can generate a HTML output also. In this case, I'm going to start by creating a PDF output. So I would click on the PDF button. So once the PDF button is clicked, it would generate the PDF output. So generally, when you click on the PDF output, the output generated is an image file. So it produces the image of the first page that you have compiled. In case if you want to go to the next page, you can keep clicking on it. Similarly, if you want to see the entire PDF, you can click on the PDF view. So this generates the entire PDF and you can see the entire PDF of the document being displayed on screen. Now, in case if I want to now, I've actually made all of the changes to the text file. I want to generate an XML. I can change it to XML and then hit the XML button. So once the XML button is hit, it immediately starts generating the XML. XML generation is a very intensive process, but TechFolio is able to do this processing within around 10 to 15 seconds or not more than 20 seconds. In this case, the XML has been generated. You could see the XML on the output screen. The entire XML is over here. I can just show you maybe some one or two mathematical constructs over here. You can see these are the mathematical constructs of the equations. Now let's go on to viewing the HTML which is now being generated from the XML. If I click on the HTML button, on the fly, the XML is rendered as a HTML and it's shown on screen. The rendering process happens in the background. Now what you see is the HTML being rendered. If you look at it, you can see all the mathematical constructs, the math equations and so on have been properly rendered using MathJax. If you click on it, you will be able to see that these are all MathJax constructs that have been created. If you want to see the mathematical code, you can click on it. You will be able to see the entire mathematical code for that particular equation rendered on screen. In case if on the tool you want to see whether an SVG can be generated from it, you can also do that. If you come to math settings, you can see math renderer, you can change it to SVG. So once you change it to SVG, immediately it starts typesetting and then displays the entire SVG content on screen. So these are some of the few important functionalities that you have in TechFolio. You can see beautifully rendered output on screen. And all of this rendering is being done by the tech typesetting system. So you don't lose any kind of fidelity. It's all beautifully typeset on screen. Now let's go on to the other tools that are there. See, once you generate the XML, the PDF, then you want to generate strip-ins. So the strip-ins can be easily generated from within the TechFolio tool itself. Like I said, it's a complete journal production tool. Now I'm going to generate the strip-ins. In this case, I load the strip-in toolbar and click on compile. It immediately starts generating the strip-ins. Now you can see something over here, it's quite tiny over here. You might not be able to see it, but strip-ins have been generated. And once strip-ins have been generated, I can click on the check strip-ins button. Once I click on check strip-ins, the strip-in generation happens, and from the PDF, the strip-ins are being generated. Over here, you can see the entire strip-ins for all of them being generated. Now, the strip-ins generated are in SVG format. On top, what you see is the XML construct, and what you see at the bottom is the SVG output. So these are the entire, see, you can see complex equations being generated as strip-ins. The next option that I'm just going to close this window. Let's move on to the next one. The next functionality that you have is the MSRC generation. So what happens here is there are certain mathematical constructs which do not have their equivalent XML equivalent syntaxes being generated for it. So in these cases, the tags are not present, and in such a case, you will have to generate strip-ins so that when it's rendered on the browser, they properly appear. So in these cases also, TechFolio can easily generate them. as strip-ins. You do the same thing that you did for general strip-ins. You hit on compile. It creates the strip-ins and you can check each one of them. So images of the XML are generated. Now the processing is happening. This is again quite intensive. The processing happens and you can see all of them generated on screen. I think this covers most of the important functionality that you would generally find with the tool. Now the other important tool is, in case if you want to create the complete data set, you can create the complete data set using the TechFolio tool. So you click on data set, say for example, there are various stages involved in it depending on the customer requirements. For each stage, you can generate equivalent data sets and then send it back to the customer. In this case, say for example, I want to generate this data set. I hit on it. It starts the processing. So you should understand it is completely typesetting everything and then creating the final data set for the whole thing. So whatever might be the outputs that you require, like strip-ins, XML, PDF, even running internal validation tools to find out if everything is correct can all be done from within the single TechFolio system itself. Now I'm clicking on next. So the client XML has been generated. You can next run a validation. It does the validation. All of that is checked. Now once the validation stage, I move on to generating the PDF so that the result that goes to the printer does not have any errors or so on, and you do not lose money in printing something that could go to waste. Now the PDF is being generated. The system takes some amount of time because this is the final data set preparation that is going through, wherein you want to create high fidelity images. All those things have to be done. Now on screen, what you see is the PDF view, and what you see here is the MathML view, and the one that you see on the right hand half is the strip-in view. So this is HTML rendered. This is strip-in with HTML. You can see and compare all of them so that the final results that appear on the web browser or so on are accurate and you're not missed anything. So this helps in the validation of things. Now we go on to the next stage, which is to generate the final data set. So this is running in the background now. It might take 1 or 2 seconds or something, maybe not more than 20 seconds. Now it's generating it. Now I go on to the next stage where it's going to copy all of the web images or the print images from the various systems. Say for example, artwork processing is being done by a different team in parallel. So it generates copies all of the artwork from the other systems, moves it to the TechFolio system, and then finally uses all of these images and then generates the final data set. So it's now copying the images onto the system. Once the images have been copied, everything is done. It does the validation, and then finally it generates the final XML, and the entire process is complete. Now you have a final data set which can be uploaded to the publisher, or it can be sent to print also. So with this, I conclude the entire demo on TechFolio. Thank you. In case if there are any questions related to the tool or so on, you can email us at info@stmdocs.in. Thank you.
So I think we have just seen the capabilities of TechFolio. Now I think we'll now move on to the bibliographic part, which will be taken care by Rishi and Apu. So can the host actually enable sharing for CVR Rishi? It's Rishi only, sorry, Rishi. So you will see him as Rishi T. Can you just enable sharing? Rishi T. Can you enable sharing option for Rishi? Am I audible?
Yes, I can hear you.
Yeah, you are audible.
Oh, so can you enable sharing option for Rishi?
Or you can enable sharing option for me, Apu. If there is any trouble, I will share from here.
Yeah. Yeah, very sure. So can the host enable sharing for Rishi T?
Hello. I am Apu from XTM Docs.
Yeah,
I will be sharing
I'm at a different place. I'm asking him to make you presenter. Yeah.
Okay, I will share
You
that.
are now,
Okay. Are you able to see my screen? Hello.
We can see a media player, but nothing has come up. Apu.
Okay, I have started playing. Just wait. Hello all. I am Apu from XTM Docs. In this presentation, I will give you a basic introduction to BibTeX, a bibliography management system for LaTeX. For academic and research papers, incorporating references and their citations into the document is a critical task. LaTeX has an embedded bibliography and citation system which is suitable for simple documents. However, when it comes to academic publishing, a much more robust bibliography management system capable of producing reference lists in accordance with the publishing standards is necessary. BibTeX is one such system widely used by LaTeX authors. LaTeX, being technical and scientific documentation preparation system, already provides native bibliography and citation support. This embedded system provides the bibliography environment and bibitem commands for easy creation of reference lists. But this native system in LaTeX has a few drawbacks. Without the aid of additional packages, it supports only the numbered reference key. Manual formatting using text commands and punctuating the reference list will be required. This can be a tedious task when the number of references in the document are large. The manually formatted bibliography data may not be suitable for use in another article with a different reference style, so it is not reusable or shareable. Because of all these reasons, a bibliography management system is necessary. Such a bibliography management system must have following features. Generating the reference list for various bibliography styles without manual formatting. Keeping the reference data separate from the main document so that it can be reused in the future. Providing a consistent format for maintaining the reference data so that it can be shared among the fellow users of the same system. BibTeX bibliography management system was developed by Oren Patashnik and Leslie Lambert. It was first released in 1985. BibTeX is written in Web and Pascal languages. Current version is 0.99D, which was released in 2010. It is included in all available LaTeX distributions like TeXlive, MikTeX, etc. BibTeX is widely used by authors for managing reference lists in their papers. Now let us see how BibTeX system is organized. BibTeX system consists of a BibTeX database file, style file, LaTeX manuscript, and BibTeX parser program. Bibliography data is kept in a style-independent text-based file format. The file extension of such files are bib. This file is commonly referred to as BibTeX database or simply bib file. Since bib file does not contain style information, we need a file which contains all the style-related data like italicization, bolding of text, order of surname and given name of authors, punctuations, etc. These style files have the extension BST. BibTeX already provides BST files for commonly used reference styles such as numbered, APA, IEEETR, NSRT, etc. Also, most of the journals that support LaTeX provide their own BST files for authors' convenience. The LaTeX manuscript will contain commands that specify which bibliography database and reference style are to be used. BibTeX parser is a command line program that uses this information from the manuscript to generate the reference list from the BibTeX database file by applying the style file on it. We will see how this process works later. Now we will see how BibTeX database or bib file is structured. BibTeX database contains bibliography entries, each of which corresponds to a reference item. Each entry consists of a reference entry type, label, and the bibliography data specified as key value pairs. This is how a BibTeX entry looks like. As I mentioned earlier, BibTeX entry consists of an entry type, label, and reference data. The entry type specifies what type of reference it is. For example, article, book, or proceedings. Entry type should always start with an @ symbol. The label should be a unique string for each entry and is used for identifying a reference item and citing the reference entry in the manuscript text. The data for reference item is kept as a key value pair with the keys or fields indicating what kind of data it is. For example, author, title, pages, etc. The label and reference data are kept in curly braces. There should be a comma after the label and after each key value pairs. Common entry types are listed here. Their names indicate what reference types they are. Article, book, conference, in book. Miscellaneous, unpublished, etc. These are the most commonly used entry types. These entry types are defined in the bibliography style file. If we use an entry type that is not defined in the style file, BibTeX parser will throw a warning. Entry type for label is not style defined. As I specified earlier, the entry type name is used after the @ symbol in BibTeX entry. This table lists commonly used BibTeX entry fields or keys. Depending on the entry type, some fields may be mandatory for an entry type. For example, for article entry type, author, title, journal, year fields are mandatory. These requirements will be defined in the bibliography style file. If we omit mandatory fields, BibTeX parser will issue a warning about empty fields. Fields that are not defined in the style files will be ignored. This is another example for BibTeX entry for article type reference. There are few points to notice when entering data for the fields. Author names are in the first name, surname order. Bibliography style file will format them according to the rules specified in it. Each author is to be separated by AND. Page ranges can be specified in pages field. The ranges are separated by a double hyphen. Braces are used to protect strings from the formatting rules applied by style file. For instance, in the example, if CTAN in title field is not included within braces, the style file may format it in sentence case. To retain the capitalization, we group it in braces. This will ensure that BibTeX parser excludes that string from style formatting. LaTeX comment character percentage is not a comment character in BibTeX database. All text between entries are ignored. So if you want to ignore an entry, just remove @ symbol before the entry type. In case you want to ignore a field, just rename it to a field that is not defined in the bibliography style file. For example, to ignore pages, just change it to XX pages. But authors may not have to worry about such things, since online services like Google Scholar allow the export of bibliography data in BibTeX format. Authors can copy this data as it is and create their BibTeX database file. We will see how easy it is later. Next component of BibTeX system is BibTeX style file. Bibliography style file contains all style related information for the reference list, like formatting, punctuations, and order of the contents. BibTeX by default comes with the style files for all common reference styles. These style files have file extension BBL. These style files are written in a custom stack-based programming language unique to BibTeX. Most journals and publishers that support LaTeX provide their own BibTeX style files that match their reference style. So authors need not to worry about writing their own BST files. BibTeX parser generates the reference list using the BST file by applying it on the bib file. Common bibliography styles are listed here. Plain is a numerical reference list sorted in the order of the citations in text. In alpha style, reference lists are sorted in alphabetical order of the author's surname. ABBRV is a numerical reference list sorted in the order of citation in text with author's first name shortened. ACM is similar to ABBRV with some formatting references like author names in small caps. APA-like is an author year reference style that follows APA citation rules. IEEE-TR, a numerical reference list which follows IEEE transactions reference styles. SIAM is a numerical reference list used for some mathematical journals. Un-SRT reference style is a numerical reference list that is not sorted by citation order used in the text. You can find detailed information and how each BibTeX entry types appear in each style at the website bibtex.co. Here is a table that summarizes common reference styles, author name format, citation format, and sorting style. Journal or book publishers usually provide their own bibliography style files. These are designed by style designers to match journal's requirements. So authors don't have to spend their time searching for which reference style is to be used. Now we will see how reference lists are generated by BibTeX, and it is included in the LaTeX document. LaTeX comes with two commands to select the bibliography reference style and the database file in the document. Bibliography style command selects which style file is to be used for reference list. Command's argument is the style file name without BST extension. For example, bibliography plain will use plain bibliography style for formatting the bibliography database. Bibliography command selects the reference database. Its argument is the reference database file name without bib extension. Multiple bib files can be used, separated by commas in the bibliography command's argument. These commands are placed at the end of the LaTeX document where the reference list is to be printed. This is a graphical description of bibliography generation using BibTeX system. BibTeX reference list generation is a 4-step process. We will be using BibTeX with PDF LaTeX in this example. Step 1 is to compile the document. During this first compilation, LaTeX will read the bibliography style and bibliography commands from the manuscript file, and the files to be loaded will be saved in the auxiliary file mydocument.aux. Also, the reference labels used in the cite commands are saved in the aux file as well. Step 2 is to run the BibTeX command with manuscript name as argument. Now BibTeX reads the auxiliary file and generates the reference list and saves it to a file with the name of the document and extension BBL. That is my document BBL in this example. The BBL file contains the bibliography environment and the bib item list with formatting commands and definitions. Step 3 is to run the PDF LaTeX again. Now LaTeX reads BBL file and insert the bibliography at the place of bibliography command. Bibliography command reads the BBL file and includes the reference list. Finally, run PDF LaTeX once more. LaTeX replaces the cite commands used in the manuscript with the reference numbers or author year names used in the BBL file. If you make any changes to BibTeX database file, you have to follow these steps again. For simple style-related changes, you can edit the BBL file, which uses standard LaTeX commands. The BBL file will contain only the references that are cited in the text. If all reference entries in the bib file needs to be in the reference list, use noCite command. NoCite command will be used before the bibliography command with asterisk as its argument. Next, we will see how NatBib package helps in citing references in manuscript. By default, LaTeX provides cite command for numerical reference citation. For advanced numerical citation styles and author year citation styles, NatBib package is widely used with BibTeX. Though NatBib package can be used also without BibTeX, using it with BibTeX provides a very convenient reference citation management scheme. NatBib package supports all numerical and author year citation styles. It automatically sorts numerical citations and compresses ranged citations. For author year citations, NatBib provides additional commands which are listed in the table. Cite command is used for in-text citations. Cite P is for parenthesized citations. Starred version of these commands will list the full author list in the citation instead of et al. Version. Cite author is to cite only author names. Cite year is to cite only year of publishing. Cite ALT and Cite ALP are versions of Cite T and Cite P without parentheses. Here is a minimal example of a LaTeX document using NatBib and BibTeX for reference citation management. NatBib package is loaded with the numbers option for numbered citation scheme. Cite command is used in text to cite references. Bibliography and bibliography style commands are used at the end of the documents, where bibliography list is to appear. Now I will show how to create a BibTeX database file using Google Scholar and generate a reference list in the document. I am using the TechFolio online text editor for this demo. TechFolio is a cloud text compiler. It also supports reference list generation using BibTeX. Here we have opened a LaTeX document in the editor pane. Else article class is used as the document class. Since else article already loads NatBib, loading NatBib package is skipped. In the document body, two cite commands are used. Bibliography and bibliography style commands are used at the end of the document. In the generated PDF, you can see reference lists are missing and the citations are appearing as question marks. Now, let us create a simple BibTeX database file. From Google Scholar, we can search for a book. Here I am searching for textbook. Click the citation link, the double quotes icon. In the pop-up window, click BibTeX. Copy the BibTeX entry. Now in TechFolio, create a file refsbib, the BibTeX database file. Edit the file and paste BibTeX entry. Similarly, search for another article and paste its BibTeX entry to the refsbib. We are using bibliography style model 1 num names, which is a numbered reference type. The bibliography command already contains the database name. Now let us do the 4 steps to generate the reference list. Compile the document. From the Tools bar menu, select Run BibTeX. Compile 2 more times. Now you can see the reference list and citations are printed in the PDF. Now let us change the reference style to author year style. Add author year option to document class. With this option, else article class will use NatBib package for author year citations. Change cite commands to cite T and cite P commands provided by NatBib package. Set bibliography style to model 5 names, which is an author year's reference style. Then follow the same 4 steps as before. Now PDF is generated with author year reference style and citation without any manual formatting. Now we will see how to generate reference list from command line. I have opened the manuscript text file in editor. Bibliography file refsbib is already saved in the working directory. First, we compile the document using PDF LaTeX. Then run BibTeX. Then compile twice using PDF LaTeX. Now PDF is generated with reference list and citations. Now we will generate reference list for author year citations. Just by changing a few LaTeX commands, we are able to generate reference list in author year format. Another feature of TechFolio is BibTeX formatter. BibTeX formatter can convert reference items tagged in LaTeX native bibliography scheme to BibTeX entries. In this example, there are two reference items in the bibliography environment. We open the BibTeX formatter from the menu. After refreshing the window by clicking the refresh button, reference items in plain text are converted to BibTeX entries. It is possible to fine-tune entries generated by the BibTeX system using the built-in editor. Once BibTeX entries are checked, we can save them to BibTeX database file and use it with BibTeX. So here I am summarizing the advantages of using BibTeX system with LaTeX. Obtaining bibliographic information for BibTeX is very easy since most reference database services allow the export to BibTeX format. For example, Google Scholar, Web of Science, RefWorks, JabRef, etc. Since the reference data is kept in a separate file, it can be used across multiple papers and share with others. Bibliography style files are readily available. BibTeX together with the NatBib package allows easy generation of the reference list and citations according to the publication standards without any manual editing. Custom reference styles can be generated using a command line utility called makeBST. This interactive command line program asks various questions related to reference styles and generates BST file accordingly. But there are some drawbacks to BibTeX system. The bibliography style customization is not an easy task due to the custom stack-based language it uses. This language is unique to BibTeX and follows reverse Polish notation, which is unconventional in modern times. UTF-8 encoding support for BibTeX is not adequate. In future release version 1, it is expected to have full Unicode support. BibTeX program is not actively developed anymore. Latest release was in 2010 version 0.99D. BibLaTeX Biber system is a modern bibliographic management system which is slowly replacing BibTeX. BibLaTeX Biber system uses the same database file structure as BibTeX. So existing bib files are compatible with the BibLaTeX Biber system. Biber is written in Perl language with the aim of providing a customized and sophisticated data preparation backend for BibLaTeX. In this system, BibLaTeX package is used to format reference lists and citations instead of BST files and NATBib package as in BibTeX. With the BibLaTeX, LaTeX macros can be used for customization of bibliography styles, which is more convenient for LaTeX authors. Also, BibLaTeX Biber provides full support for UTF-8 encoding compared to BibTeX system. You can find more information and tutorials about BibTeX and BibLaTeX Biber from these links. This concludes the short introduction to BibTeX system. Thank you all.
I think that completes the BibTeX part. So we'll just look at if there are any questions. If there are any questions, we'll answer.
Yes, Yogesh Kumar asked, can we feed the text document directly into plagiarism checking facility? Since the text file is a normal text file, you can feed it to the plagiarism checking utilities and test for if it breaks any plagiarism rules.
That's the only question that's there. Then I guess we can move on to the next one.
Yes, sir. I think you can move on to the next session.
Yeah, we'll move on to the next session. So that is the last session from our end. So,
Yes,
so we'll just present the final thing and then we'll move forward. Okay. So just give us a second.
Yes, sir. Thank you, sir. So who will be the presenters for this session?
Presenters, I think I'll present it from my machine itself. So there's a lot of rain over here. So that's why to have to keep a backup and so on, because the lines are getting disconnected frequently. So we have made some recordings. So I'll play the recording from my end. And then at the end of it, Rashmi and Akshay will take the questions.
Okay, fine.
So the last session is about online tools. So we'll just move on to that session. So if you look at the various stages that are involved in journal production, so it starts with submission, then it moves into peer review, then we have the typesetting stage where we have proofing, copy editing, artwork processing, and then the various output are generated. So in terms of various online tools, so this is how the entire online tool portfolio can be split up in terms of how we see it. So the entire journal production tool, so in the submission space, we have something called as Techfolio Alpha. So Techfolio Alpha is a cloud service which helps in the submission stage of LaTeX articles, specifically to cater to the completeness and usability check. So each and every publisher will have their own checks. So catering to those requirements, we have specific checks which can be done. And any research author would have their own manuscripts generated in LaTeX, and the manuscripts would be pushed into the completeness and usability check tool. It will do the checks, it will generate a report, and based on that report, the author themselves can make changes to their LaTeX articles and then carry out the submission again. So this avoids a lot of delay in terms of getting these things corrected by the author and then the article moving to the publisher, again coming back to the author to make the corrections and so on. So in the first stage itself, these problems can be identified and the check can be completed. So that is the advantage of the Techfolio Alpha system. Now, the next stage is the peer review stage. Here we have a system called as the Neptune reviewing system. So Neptune already has a system called as the author proofing system. This is an offshoot of that particular system itself. One second. So this is an offshoot of the Neptune author proofing system itself. So how it happens is the changes that are required to be done by the author based on the peer review. The peer reviewer looks at the manuscript on the Neptune system, they make those changes or they recommend those changes. Again, the document comes back to the author. The author also looks at the Neptune system, makes those changes. So this back and forth process of articles moving from the author to the reviewer, again back to the author, those sort of things can be done in one system, and it reduces huge amount of time. So this is the advantage of the Neptune reviewing system. The next thing is the Techfolio and Neptune proofing system together. So Neptune Techfolio acts as the typesetting system. It also helps it is also used by the copywriting team. And in that particular Techfolio system, the journal production can be completed. So ETHL is also a different system which works just like the Techfolio system. Only difference is ETHL is used for non-Latin publishing. So in the coming slides and the presentations, you will be able to see all these tools. The next tool is the Neptune. Neptune is the proofing framework. It is used by LaTeX authors. So as of now, Neptune is used by Elsevier. So the customer feedback has been very good. And as of now, the customer satisfaction is around 95%. The last system that we have is the Neon. So it's more on to how data is stored, and from that particular archive data, how you can actually produce PDFs and so on. This is the Neon system. Now, the advantages of all these production tools are like they are all built on the modern UI interfaces for the web. They are a flexible modular system wherein each module, say for example, your EPUB module or the PDF module, HTML module, the generation of validated XMLs, then the validated PDFs, all those things are modular systems. You can actually add these systems or remove them. That sort of a thing is easily possible. Next, the other advantage is they are all systems which are there in the cloud. So you can use all of them by sitting in any place across the world. There are two ways in which you can use the system, either through the web interface or as a microservice. So when I say a microservice, there are API you can use. Using the API calls, you can call them. You can do all of the compilation of your text files, everything through the system, completes it, and then it gives you a result. So these are the advantages of using the journal production system that we have. Now let's look at the two ways in which the system works. It uses an XML as an input, or it uses the LaTeX as an input. So both the strategies are supported by the system. So we call this as the X-around process, wherein as and when you want to actually make changes, so you would be doing those changes in the LaTeX file. From the LaTeX, we will generate an XML, or if it is the other way around, from the XML, we can produce a LaTeX, and then that LaTeX is used for generating the final PDFs or the various output variables that we have. We can keep doing that in a cyclic process. Now let's look at the important tools that we have. Techfolio, we had explained all these things to you earlier. So we have also seen a demo of it. So this is the same tool that is used for the journal production at our end. Now Neptune is the author proofing tool. This tool will also be discussed in detail in the next presentations that would be shown to you. So finally, these are the various tools that we have in one view. You will be able to see them. On the left, first one that you are seeing is the TechFolio Alpha system, which is the completeness and usability check tool. Second one on the right that you see is the Ether. This is used for non-Latin book production as well as journal production. So this specifically what you see there is the Malayalam language or vernacular language of Kerala, whereas it can be tweaked or can do the same for any other language across the world also. The other tool that we have is TechFolio, that is used for Latin publishing. Mostly all scientific work is being done through the system. And the last system that you see is Neptune, which is used for author proofing as well as more of a reviewing system. Now, as we stand, those are the tools that you saw. So in the future, the tools that are coming out are the HTML proofing solution. So whatever you've seen there are all LaTeX-based tools for the LaTeX scientific or LaTeX community. The new tools that are coming are the HTML proofing solution, then the authoring tool. These are the two tools that we are working on. So these would be coming out by the end of this year. So these ones, they are out, would be mostly game changers, wherein you will be able to do all of your work and then produce publisher quality or publisher specific PDFs or any sort of deliverables by just a click of a button. So those sort of things will come by the end of this year. The other key areas we are working on are the tag PDF, and this would be delivered by around 2022. So who are our key users? So as of now, we have Sayana Foundation. So they are mostly into open access publishing. They help preserve the entire literary works which are there in Malayalam. So they do a lot of digitization related to it. So Sayana Open Access Publishing uses the tools which we have created. So they specifically use the Ether tool. Then STM docs, over here we have two projects. One is Elsevier and the other one is PeerJ. Elsevier operates on the traditional model and PeerJ operates on open access publishing. And in both cases, we use the TechFolio, Neptune, all these tools are used. And similarly for Elsevier, the Neptune service is also being used by Elsevier. So every year we do around 250,000 pages. So we've been doing something like this for the last 20 years. So everything that is complex and related to scientific journal publishing, all of that is, we have already faced all the challenges that are there, and all of those things have been addressed, and in the tools use all of these things. The next one is the open access publishing. So this is where we're talking about the cluster publishing or the idea of self-publishing. Here, this is a small journal. So they release around there are 4 releases per year. And in this case, they use our TechFolio and Neptune tools. So they don't directly use it. We typeset all of their work for them, but the typesetting happens through these two tools, TechFolio and Neptune. And the other key user of our tool is DC Books. DC Books is a leading publisher in Kerala. So earlier they were using proprietary tools like Adobe and so on. And from that they have moved into using the LaTeX-based system, which is Ether. And this single tool is now doing all of their book production work. It generates EPUB, XML, PDF, all seamlessly within seconds from a single input. So they are completely moved to using LaTeX. And then the last project that is there is Janayugam. The reason why I brought in the Janayugam project is because LaTeX as a typesetting tool is very good at doing or scientific related to work and so on. But when it comes to production of multi-column layout documents, LaTeX does not shine that well, or it can do that particular work, but the amount of expertise that you need or the difficulties that you would face are much more than what you would find in other tools. So this is where open source project called as Scribus. The Scribus tool is quite good in actually trying to do work wherein you don't need the power that LaTeX provides, but you need more flexibility. So Scribus is a YCV creditor, more like InDesign, and you could use Scribus for say production of magazines, those sort of work. And Janayugam is a Malayalam newspaper which has been published from Kerala, and they moved their entire production from using proprietary tools to using the Scribus tool itself. Now every day newspapers are being rolled out using this particular Scribus tool. So that covers the key users. So the reason why we wanted to show you who are the key users is because LaTeX is not alone used in the scientific community, but it is used in the industry as well in across various places or various key users of LaTeX as what you see here. Now, the reason why we have been presenting all those things is because we want to promote scientific research, specifically scientific research in India. And India is a cost-sensitive market, and we always want to actually provide very good tools for the scientific community so that they can do dissemination of information across the world very easily. So in case if a server instance is provided, we are happy to deploy the TechFolio in the form of a service, and it's as low as $0.25 per user. So generally any competitor tool that you see, you might have to pay around $15 or something for one user. So this is generally we provide these services to the business users for around $100 per user, but we now for the institutes like yours and the scientific community, we want to actually give this as a service at very meager cost, which will actually help us maintain the systems alone and nothing more. So this is something that we want to offer all of the scientific community. And in a way, if you want, we can actually do all of this maybe free of cost for 6 months or something. And after that, then you can think about these costs. So advantages of moving with these tools are like other tools and so on. There are privacy related issues that you may face, wherein you're not in control of the data. You'll have to host the data in their servers. In our case, that would not be the case. We are happy to deploy our software in your servers that or instances that you provide, and you can actually take care of the content and the data by yourself. And in addition to that, we want to promote self-publishing by institutes which have good journals in their hand, which they are already doing by themselves. The only thing is you don't have to rely on other typesetters. You yourself will be able to produce industry standard, well presented articles for all of your journals that you are supporting. Then we also want to provide LaTeX support so that people who are facing difficulties in producing the manuscripts can actually come to us for support and we could help them. And the other thing is the experience that we have gained in terms of the standards that have to be followed. All of that information, all of that knowledge that we have gained can be shared with all of you through a consulting exercise and so on. The other thing is, in case if there are institutes which want to have their own journals, have their own styles, and then in those cases, we can provide the expertise to develop the class files for you. So these are the key offerings that we want to offer you as part of this presentation or this entire thing, because we don't want to let down the scientific community and we want to offer you something. That is why we want to do this. So I think with that, we'll conclude, and then you can look at the demo of Neptune and XPC. So XPC is the tool that we use for producing PDFs from an XML input, and Neptune is the author proofing tool, which I feel that some of the authors who are there in this or viewing this presentation would have already used it in case if you have submitted LaTeX articles with LCA. So I think we will run the presentation now, the demo now. Okay.
Hi everyone, good evening. I am Jishmia Prabhu from SGM Software Engineering Private Limited. Today I am here to present our author proofing tool, Neptune, and its features. Neptune is a web-based proofing framework for LaTeX authors. In Neptune, authors get full access to their source code because its input is a LaTeX file. They can make the corrections in the source code according to their requirements and view the changes in the output as PDF side by side. It was launched in November 2018 and all the latest web browsers are supported by Neptune. Proofing stage is a very crucial stage in the article publishing. Most of the proofing systems available now are based on the HTML rendering, where an XML file is used to render the output and the authors have to make the corrections in the HTML page. They have no idea on how the final output will appear. So, authors request for revised proof after correction stage. Sometimes if author missed to do any corrections and the article is published, then to include the correction again is a tedious process. For LaTeX authors, this is a very difficult process since they know how to correct the source code to get the required output, but they are unable to do so. Here comes the advantage of Neptune. Since authors get the source code and in Neptune, and it provides a wide variety of features that helps the authors to complete the proofing smoothly. Before moving to the features of Neptune, I would like to explain briefly the procedure behind the preparation of author proof. After acceptance of an article by the publisher, we get the source through a centralized booking system. The article is processed according to the journal style. First, it is proof-checked by the in-house editors, correct any spelling and grammatical errors. Layout is finalized. Finally, it is posted in Neptune after QC checks. The Neptune URL is shared to the corresponding authors through email. Authors do the corrections in the Neptune page and verifies the output. Finally, he submits the article in Neptune. The article is moved to the next stage, master copying. In master copying stage, author comments regarding artwork or any other comments are carried out, and finally the article is published. This is the landing page of a Neptune URL. You can see the journal logo, article title and other details including copyright information is available in the left side, whereas on the right side there is a link to user manual which contains basic coding instruction and help button having a brief tutorial about the functioning of Neptune and link to publisher guide. By clicking proceed button we can start proofing. We can view the original link and discuss the features. This will be explained by my colleague Akshay.
Thank you, Rashmi. Hi everyone, my name is Akshay and I'll be explaining the various features that Neptune provides. The most significant feature will be the freedom to edit the source code and view the changes then and there itself. Others can make changes in the text editor, then compile the text and view the changes in the PDF view. I have just added a sentence here and I am compiling it, and as you can see that the corresponding output is automatically generated. There is an ignore compilation mode to bypass minor errors so that the others can process without worrying about the error. Large edits for figures, tables and equations can also be made. So here I'll try to make a few edits. I think I will select an equation here, and so this is equation star environment. That means it is an unnumbered equation. I will change it to begin equation, end equation, so that the equations are numbered, and I will compile it to check the output. As you can see, the first unnumbered equation has become a numbered equation, and also all the following equations, all the consecutive following equations have been renumbered accordingly, and there was a citation of the equations here which has also been changed. A functional tracker is available to track all the edits made in the source file. making it easy for the authors to keep tabs on the proofing process. The tracker also records changes to the table of contents, figures, tables, and notes. It is seen quite often that the number of pages for a single PDF may exceed more than 100 pages. While reading the PDF, if the authors wish to perform an edit in the source code instead of looking through thousands of lines of code, the author can simply click on the PDF and the editor will navigate to the respective region in the source code. So I have just clicked at the beginning of the sentence here, beginning of a paragraph here, and the editor navigated to the corresponding location in the source code. All the PDF viewers provide a vertical scroll option. Neptune also has a horizontal scroll option which allows the user to compare different pages side by side and check for pagination errors. If the authors find it difficult to make certain edits, then they can add notes in the source code or add comments. These comments will be implemented by the production team. It's quite a simple procedure. Just click on the additional comments tab and add your comment and press the save button, and it will generate a bell icon there which will alert the respective users to implement the changes mentioned as the additional comments. A query panel is available which acts as a medium of communication between the production team and the authors. Production team can post queries here regarding the article and the authors can add their responses. This panel can be hidden to free up more space for the editor. A search and replace function is also available which allows to make multiple edits together. This function also supports regular expression which allows you to handle more patterns efficiently. The generated PDF output has hyperlinks and bookmarks that can be accessed with a simple click. Authors can upload new figures or any additional material through the upload wizard. Many themes are also available which the users can use according to their preference. The text size also can be varied according to preference. There is also a provision to compare the edited and non-edited source code and the output PDF in synchronized windows. As you can see here, it is quite easy to locate the changes that were made in the source code in this window, source comparison window, and in the PDF comparison window all the respective edits can be verified visually. Since the author can see how the final version of the PDF will appear, there is no need to perform proofing more than once. Also, we provide 24/7 support for Neptune users facing any difficulties. All these features were developed based on the feedback from various authors around the world. And 2 years after the release of Neptune, we are proud to share our success story with you. I invite Rishmi to mention a few highlights of our achievement.
Thank you, Akshay. One of the largest publisher who publishes 5 lakhs articles annually in 2,500 journals has accepted Neptune as their LaTeX proofing solution. From November 2018 until now, more than 18,000 LaTeX articles are proofed out through Neptune. Neptune obtained a customer satisfactory score of 95%. Authors have accepted the functionalities Neptune provides, and a survey shows that author utilization rate of Neptune functionalities is 98%. Currently, more than 300 journals are rolled out in Neptune, and more journals are in the pipeline. Thank you all.
Hello everyone, I am Akshay and I will be talking about XML page composition or XPC. Before we begin, I would like to give you an idea of what we are trying to achieve here. We see every day the world around us is filling with different kinds of automations and artificial intelligence is performing difficult tasks effortlessly. It is often questioned if a man-made intelligence can create something that a human can create. More importantly, can it capture the same essence that the human imparts to a creation? The answer to this is becoming a reality day by day. Machines creating artistic masterpieces, or an AI writing musical symphonies. These are just two examples of this reality that we are stepping into. XML page composition, or XPZ, is just another step into this reality. So what is XPZ? To understand XPZ, let us see what XML is. Extensible Markup Language, or XML, is a markup language like HTML or KML with a long list of real-world applications. One of the applications of XML is long-term data archival. XML has become an important part of data storage, and we can never completely avoid it. We have already discussed about how XML files are used in rendering proofs for HTML-based frameworks and its disadvantages. XPC is a typesetting system in the cloud which can automatically create aesthetically pleasing PDF using TechFolio directly from a valid production XML. These PDFs are standard compliant PDFs. TechFolio is the tech-based typesetting framework which was discussed earlier. The main challenge in using XML is that it is just a large collection of data stored in different tags. There is no shape or form to it. To generate a proper PDF from this was our first challenge. Thanks to LaTeX, this challenge was overcome. As we know, an article, let it be scientific or otherwise, is never just text alone. There are figures, tables, equations, references, and so much more. Even if we manage to create a PDF from the XML, there will always be new challenges like placement of tables or figures, calculation of table widths, ensuring data protection, and so on. These challenges were overcome after multiple testing stages, and now we have a stable product with a lot of features. These features make the process of generation of PDF from XML a lot more efficient. The workflow of XPC is fully integrated in the cloud. There is no requirement for any additional storage spaces. The workflow is fully automated from the fetching of XML code to the generation of PDF. To ensure that all the content from the XML is available in the PDF, XPC performs an high-level automated QC between the PDF output and the XML. Even if there is a need to manually intervene for an article, the users can make use of a control file which controls important aspects of the article. This means that there is no chance to edit or alter the contents of the source code, and this in turn avoids any accidental human errors. XPC uses AI for table formatting and float placement, which further reduces the need for manual intervention. Currently, XPC supports 11 languages. This can be expanded in the future. Table formatting is adaptable to single column or double column articles. APIs are available to support command line operations for automations. XPC also generates a report PDF that contains all the data regarding the article, such as position of the figures and tables, number of authors, sections, and so on. This acts as a guide to the article, and it even shows if there are any issues that need to be handled manually. Data protection is always a concern for authors. XPC provides complete data protection by eliminating the need for manual intervention. This is the dashboard of XPC. All the files and the output will be listed here. This is a sample output page from an article processed through XPC workflow. The table is formatted and the figures are placed automatically. No manual intervention was done in this file. This is all just pure AI. The results at the end of the testing process has been quite promising. We have tested more than 600 articles, and 70% of the articles were generated fully automated without any need for manual intervention. The time taken for completely processing the PDF is leaps and bounds ahead of the time taken for manual methods. XPC is currently at a capacity to handle 250 articles per day, and with an average of 15 pages per article. We are in the stage of pushing the limits with XPC and improve this further in the hopes of achieving 100% automation. We'll have a small demo now, and then we will answer any questions that you may have. I'll be using the shown command to run XPC. As soon as I run the command, the script will fetch the XML and the required assets. The XML and the assets will move through different stages of the algorithm, and the algorithm will try to generate a PDF. It will take a few minutes to download all the assets. The PDF has been generated from the XML, and now it is generating the report PDF. Let us have a look at the PDF. As you can see, the XPC workflow completely on its own has generated production ready article in under a few minutes. All I did was run a command in the terminal. As you can see, all the figures are perfectly placed near their citations. Also, the final page of the columns are balanced perfectly. This is the report PDF. As you can see, all the details regarding the article is available here. That is all with the demo. Thank you for your time. We'll take questions now.
So most of the tools that you have seen, so from the author's perspective, the main tool that you might actually be interested in would be Techfolio and Neptune. But why these tools are generally important is like in case of say some of your institutes or the university wants to move into self-publishing, then these tools will be very critical for you. Because in case if you want industry standard publications or you want to produce high quality in terms of style, look and feel, and such things, if you want to do it, then these tools are the first thing that could actually make those things possible for you, and the cost involved will not be exorbitant. But in case if you want to do all of this by yourself, then I don't think the institutes or universities would be even be able to move into self-publishing or what we call as cluster publishing. And that is one key aspect that is related to these tools. And that is why we wanted to showcase these things to you, because as such, as an author, if you want to use these tools, these may not be of much value to you, apart from Techfolio and Neptune, which are like replacements of Overleaf, or Overleaf also does not have an online author proofing system which run specifically only on LaTeX. So they do not have that functionality, whereas Neptune can do that. So this is where it is important, and how we work with the various suppliers. That experience has also been brought into these tools, and that can help the entire scientific community is what we feel. And that is why we are offering these services to educational institutions at very meager cost, just to maintain these systems as such. Other than that, there's not much that we are looking for. So, and there was a question that somebody asked whether there are material related to these things that we've presented as part of these presentations. So there are some phone PDFs that have been created. So I'll just show you some of them. And these were created so that when you're seeing these presentations, you will be able to understand them better. So that's the reason why the phone PDFs were created. I'll just share them to you so that you can see them. So a phone PDF, the difference between a regular PDF and a phone PDF, I'll just explain it to you. So generally, when you talk about a PDF, it's a full screen view that you get. A PDF would generally formatted for larger screens like our desktop systems. A phone PDF is specifically created so that it can be actually viewed in a phone sort of a device or a tablet. So it's specifically created for that format. So let me show you a specific phone PDF. So this is a phone PDF which is created in the Techfolio system using LaTeX. So you can see how it has been presented. In case if you open the same PDF in a phone, you will get a beautiful view. Because this is a large screen desktop, that's why the aspect ratios have is actually not fitting the exact screen as such. So this is the entire content which Radhakrishnan presented. You can see this. So this is one single page, which is where you get the experience of almost reading an EPUB like document in your phone. So this entire thing is a phone PDF. If you have a mobile device, if you open these things in them, then you will understand the power of a phone PDF. If you want, I can show you the other ones also. All of these content are specifically created for phone PDF, and you can. So on a phone screen, you'll be able to see it. You can scroll it as though you're reading a book. You can read them at any point in time or based on your leisure time and so. So we have produced the phone PDFs for all of you so that you can refer whenever you want and work with it. Also, the file size is extremely small. So this is what Rahul was explaining earlier. So entire content is available. You can get it from there. And in addition to that, we will upload it into our portal also. So you can download it from there. There are no restrictions in terms of how you want to use it. So we would want you to share this with others so that they will also get to use it. I think we can conclude with this. So I think we are done with our presentations. So if there are any other questions or something that you want to discuss with us, we can take those.
I think there are no further questions, so we can call it a day now. Thanks to all the speakers from River Valley, Krishnan sir, and all the team from River Valley and STM Software Engineering. So thanks to the participants. We'll continue this program again tomorrow from 2 p.m.
Yeah, before and like we said, in case if you are interested in any of the tools, then you can contact us. We will help you with those things.
Yeah, all these lectures are on YouTube. So for any contact info, you can also look at the YouTube links. Even in the YouTube videos, you'll be able to find the contact information. Or you can contact us, the organizers, and we can pass on the contact information of the River Valley team to you. Thank you, sir.
Yeah, thank you. Yeah, thank you. And thank you all for giving us an opportunity to present all these things to you. Because the research community is what matters at the end of the day. So that is why we actually came in and wanted to present these things to all of you. Thank you.
Thank you, sir.